and we are ready to hear Simon give us a bit of a history lesson. Welcome.
Right. Great. Yes, we have actually got him up. Right, welcome to 30 years of Java. How did we get here? So I'll just start with a little bit of history about myself and why I'm going to talk to you about 30 years of Java history. So I started at Sun Microsystems on, I think it was February the 16th, 1996. And I joined Sun at that point not to do Java, but to do Solaris. Anybody here remember Solaris? OK, good, yep. And I quickly found that the whole idea of Java was going to be a big thing, so I thought to myself, I need to get into this. And so I did. I started doing things around Java, and my first presentation on Java was in 1997. And this is the slide from that presentation. That is the opening slide from my very first presentation on Java. I am that sad that I keep all of these things. What's really interesting, though, was I couldn't actually load that into PowerPoint. It was a PowerPoint presentation. I couldn't load it into modern PowerPoint because it was so old. What I had to do was use OpenOffice to load it as an old PowerPoint presentation and then save it as a new PowerPoint presentation. But I did manage to actually do that. And I put the QR code thing up here so that you can provide feedback on my presentation. Right. So I'm going to talk about a lot of things in the time that I've got. And hopefully I can get through everything, because clearly 30 years of Java is a lot to squeeze into this period of time. But let's start, before we talk about Java, let's talk about some of the influences on the design of Java. Because when Java was released, the important thing about it was it wasn't revolutionary. It wasn't something that suddenly delivered on all sorts of new features that had never been seen before. What it really did was take a set of things from different places, bring those together in a way that hadn't been put together before. So it was a sort of holistic kind of approach to programming. And that's something that's really kind of stuck with Java all the way through its development and its history, is this idea of pulling things in from other places and using the best of different languages, different platforms, to build something that is suitable for developers. And if you read some of the history, and if you talk to James Gosling, if you're lucky enough to do that, one of the things he said about Java was he described it as a blue-collar programming language. It wasn't about being an academic language. It wasn't about being an intellectual experiment. It was about how to get things done. So let's have a look at some of the things that influenced the design of Java. Now, the first of those, you can go all the way back to 1962 and the Lisp programming language. Anybody here use Lisp? A few people, yes. I did one programming course on Lisp in my university course. And I remember at the end of it, I thought, my brain doesn't work that way. And I decided that Lisp was not for me. But Lisp did have some things which were a big influence in terms of the Java language. It was the first language, technically, to use garbage collection. Not from the very beginning. Lisp actually goes back to 1958. But in the 1962, much more modern version of Lisp, they introduced the idea of automated memory management and garbage collection. It was also the first language to sort of use just-in-time compilation. It wasn't really proper JIT compilation. It was what they called compile and go. Because in the very early days of Lisp, it was on punched cards. So you actually had this situation where you could do some compilation into new punch cards and do it that way. So it had that sort of influence in terms of those features. Next thing to look at is Simula, or Simula 67. And the reason this is so important is because it was the first program that was object-oriented. Java, as a language, is obviously object-oriented, so it has all of the things that we would expect, like inheritance, encapsulation, polymorphism, and so on. One of the other things that's important about Simula was, as far as I can tell from what I read, it was the first programming language that James Gosling learned how to use. So again, had some very big influence on the design of the Java programming language. Then we move forward to 1973, and we see the introduction of the C programming language. Brian Kernighan, Dennis Ritchie, working on the Unix operating system, developed this programming language that was targeted at systems-type applications. Now, C was derived from B, which is kind of logical. You have B, then C, and that came from BCPL. The reason this is important is because if you look at the syntax of Java, it's heavily based on C. Things like the while loop, things like the for loop are straight out of C. The switch statement is straight out of C. The reasoning for that was because James Gosling wanted people to be able to move from a familiar language to Java without having to learn a whole lot of new syntax. So it had that familiar feel straight away in terms of the basic fundamentals of the language. Then we move to 1978, and we have Pascal. Anybody here use Pascal? Ooh, lots of Pascal people. So Pascal, in 1978, introduced the idea of P-code executed directly by an interpreter, which implemented a virtual machine. So it was not technically the first virtual machine, but it was the sort of first virtual machine in its true kind of sense. There was another language that was O-code that came out in, I think, 1960-something. And that had a sort of basic ideas of a virtual machine. But if you want to really kind of be picky about it, Pascal Pico was the first true virtual machine. And obviously, we've seen that as a big influence because Java runs on the JVM. Then, in 1991, we had the introduction of the World Wide Web. This is where suddenly the internet was going to be something very big, because now we had accessible information through a web browser. Tim Berners-Lee opened it to the public in 1991. Development of browsers happened. We had Mosaic browser in 1993. Again, anybody use Mosaic? Ooh, lots of people. I'm impressed. And then 1994, what was really the first public browser was Netscape Navigator. That was the one that everybody was familiar with. Right, so with all those pieces in place, where did Java actually come from? How did it actually come about? And again, let's look at 1991. In 1991, Sun Microsystems was quite a successful company. They sold a lot of workstations for high-end sort of graphical type applications. And they were a very technical company. They did all sorts of interesting technical stuff. But there were several of their engineers who were reaching a point where they thought Sun has become a little bit too bogged down in product development and not really looking at what's the next big thing. And so one of them wrote a paper which he sent to Scott McNealy, who was CEO of Sun, and said, you know, this is what we need to do. We need to go away and think about what is going to be the next big thing in computing and build it. And Scott's response was, maybe you guys are onto something. Why don't you go hide away somewhere and think about what it is? And that's what they did. So in 1991, a group of people, the 4 people you saw there, they went off and they decided they were going to move away from the Sun campus completely. They were going to go and find another office, which was in Menlo Park. I believe it was above the Bank of America. And the Project Green was born. The reason it was called Project Green was because the door to the office was green. So very imaginatively, they named it Project Green. Now, they started working on that, and they came up with some ideas. And one of the things that they did was James Gosling decided to develop a new programming language. Initially, he looked at C++ for the thing that they were working on, and he decided that he needed to make a few changes to it, but eventually, the number of changes he wanted to make to it meant that he came up with a completely new programming language. He decided to call that Oak. The reason he called it Oak was because there was a oak tree outside his window. So you can see with the naming, it's kind of like, what are we going to call it? Oh, green door. Oh, Oak. Just, right, OK, just use whatever's there. And he described this in terms of the programming language as a simple, object-oriented, distributed, interpreted, robust, secure, architectural neutral, high-performance, multi-threaded, dynamic language. He could have been in marketing. But it does represent what Java is. And the key things there are obviously it's object-oriented. It is distributed. That was the big thing. They wanted to be able to move code around the network and not just have an application execute on a single machine, but load code remotely. And so it had to be interpreted because you didn't necessarily know what platform you were going to run that code on. It had to be secure, architectural neutral, and so on. So a lot of different things went into this, and we ended up with Oak. The reason that he built this was because of this device. So the green team set about developing the next big thing. The next big thing they thought was going to be some kind of remote control on steroids. Something that you could interact with, something that would give you much more intelligence, if you like, that you could then program to do things, you could have much more control over, and so on. And this was what became the Star 7. Now, first piece of really useless information for you is why was it called Star 7? And the reason it was called Star 7 was because that's what you would type on the phone in the green office to answer your extension from any phone. Again, we can see this kind of naming thing is like, you know, look around and what's on the table sort of thing. But that's why they decided to call it the Star 7. And it's incredible when you look at this. This was 1992, so it's over 30 years ago. And it looks quite a lot like an iPad today. But of course, the technology they had back then was much, much more primitive. So it ran on a Microspark chipset, which was the Sun chips at the time, 4 megabytes of RAM. Ooh, wow, that's, you know, like big. 200 kilobits per second as a RF link. A TV screen, a touch screen, which again, in those days, very, very new kind of thing, and some kind of IL link as well. One of the other things that the Star 7 had was somebody to help you. And this is where what you see here, and what you see here, came from. So initially, the idea of this sort of helper was to be the agent. The agent was going to help you with your tasks and sort of lead you through different aspects of what you were doing. So the agent morphed into Fang. The reason he was called Fang was because some people said he looks a bit like a tooth. I think that's rather, you know, sort of nasty to say he looks like a tooth. And of course, we all know that he became Duke. And so Duke has become the mascot of Java. He even had his own comic for one episode, or one magazine. And then, of course, you've got the tumbling Duke there, which was one of the sort of famous things in terms of when you ran Java on a web browser, you could have a tumbling Duke. Before Duke came about, even as Fang or the agent, they had another idea for somebody to help you. And this was called Greenbot. Personally, I prefer Duke. Right, so then in 1992, the Green team were being quite successful, and they got incorporated into a separate company under the Sun Microsystems umbrella called First Person Inc. And then they created a specification for Oak as the programming language, and everything was going great. And it's interesting if you look at the specification for Oak, which you can find it online and download it, because it is a lot like Java, but there are some significant differences. So there are some keywords that you wouldn't expect because they're not in Java, but they were in Oak. So there's things like protect and unprotect and enum, which we'll come back to. Now, unfortunately, they put in a bid to provide software for a set-top box, and they lost this bid for Time Warner. And that sort of led to a bit of a hiatus in the project, because several people thought, right, we're not really going anywhere, not making much progress. Let's move back to Sun and find some other things to do. But then, 1994 happened. And this was when there was a kind of pivotal moment when it came to Java. John Gage, who was the chief computer scientist at Sun Microsystems, he was invited to do a TED Talk. And TED Talks back in those days were much less visible than you have today. He wanted to demonstrate some of the technology that the green team had been working on. And specifically, one of the things they'd also created was a new form of web browser. And they called that WebRunner. The reason they called it WebRunner was because a lot of the people working on it liked Blade Runner, the film, and they took Mosaic. Again, it's kind of looking around and just thinking, what should we call it? And then they used the Mosaic browser as a starting point, and then they rewrote the whole thing in Java and created a web browser. So John Gage wanted to demonstrate this as part of the technology, and he popped into James Gosling's office and said, "Can I borrow an Ethernet cable?" And James was like, "What do you want it for?" And he told him that he was going to this TED conference. So James said, "Right, I'm coming with you, because if you're demonstrating my software, I need to make sure it works." So off they went, set it all up, got it working, and then they did this demonstration. And they showed this web browser. And of course, back in 1994, web browsers were entirely static. You had text, you had maybe images, and that was it. So suddenly, what they showed was a molecule in an image. Fine, everybody looked at that and went, OK, a molecule. But then John clicked on it and used a mouse to drag it around. Suddenly, he can manipulate this molecule on the screen. And everybody went, oh, now that's really different. Suddenly, we're including functionality into a web page. We can do things on a web page, not just static information. That's going to be really interesting if it becomes big. And that led to 1995, when we had the release of Java, but also HotJava. HotJava, the browser, version 1.0. And we got the first sort of marketing slogan, which is write once, run anywhere. When they released this, really the emphasis on the whole idea was around HotJava rather than Java. It was more, let's push the browser as the new technology, and Java is just sort of adds to that to make it useful. But of course, as we all know, that's not quite the direction things went in. The other very big and significant part of that announcement, which was only agreed just before it was announced, was that Netscape Navigator, the most popular browser at the time, agreed to integrate Java into their browser. So suddenly, everybody using Netscape would have access to that, as well as anybody who downloaded the HotJava browser. So this is kind of where the initial launch of Java came from. Now, there's a whole set of other words down here. Silk, DNA, Lyric, Pepper, NetProse, Neon, Ruby, WebRunner, WebDancer, and WebSpinner. All of those were potentially the name of Java, because they couldn't call it Oak. Somebody else had trademarked that. And these were all names that they came up with that they could potentially call it. So we could have had Pepper, and we could be talking about 30 years of Pepper. Yeah, I'm not so sure about that one. Or 30 years of Ruby. That could be interesting, because, of course, there is now a Ruby programming language. Right, moving on to 1996. So Sun released Java, and they wanted to make it popular. They wanted to drive adoption of it. One of the things they did was they formed a separate division called JavaSoft within Sun. What JavaSoft was all about was the idea of trying to license Java to companies so that they could embed it into their products through web browsers and things like that. They also wrote an entire operating system in Java called, imaginatively, Java OS. It was based on a microkernel. Anybody remembers microkernels? And initially, they wrote their own, but then they based it on a microkernel from a company called Chorus in France. Anybody ever heard of Chorus from France? Well, a few people. Oh, yeah, well, you're from Sun, so yeah. Yes, so I remember working with them when I was at Sun as well. And this led to what was called the Java Station. Now, this is kind of interesting, because there were two versions of the Java Station. The first was called Mr. Coffee, and it was basically just a rectangular box, which was a Sun workstation kind of rebadged sort of thing. And then they had this much more stylish Krups machine. And the problem with this, because what it was really designed to do was to replace dumb terminals with something that was a sort of smarter terminal. It was designed to be cheap, it was designed to be easy to deploy and so on, and you could just have a smart card and log in and all sorts of things like that. But it really did suffer because the technology in the day just wasn't up to it. So I remember I had one of the first Java stations, just the sort of rectangular box, and it only had 8 megabytes of memory in it. And that really wasn't enough to run the Java virtual machine and applications, certainly at any kind of realistic speed. So it just never really took off. There were plans for a third version called the Super Java Station. That was going to use Java chips, which I'll come back to later. But that one never saw the light of day. The project really kind of morphed into, now what was it called? We had one at the Sun. It was like a Sun workstation thing with a smart card on it. But that's kind of where it ended up. And then in 1996, the other thing that was really significant in terms of helping to drive adoption of Java was that Microsoft said, aha, right, so Netscape's got Java in it. We need to have that in our browser called Internet Explorer. So Internet Explorer in 1996, version 3, shipped with Java. Great. Right, now I want to take a little aside here, because I want to talk about version numbering in Java. And I find this really entertaining. I hope you will too. So we'll just take a little sort of side trip into Java versioning. So in 1995, Java, the very first early access was released, and it was called Java 1.0 Alpha. Now, I didn't manage to get access to a copy of this. I didn't have one. So I don't know what the version string that came out of that was. But in 1996, just before I joined Sun Microsystems, Java 1.0 was released. Now, this is good. You see, this is logical, because we have 1.0, version 1.0. Very good. And if you look at the version string, because I did find one of the JDKs from there, it says Java version 1.0. Again, very logical. Two things to note about this. One is they put quotes around the 1.0. Not really sure why they did that, other than maybe for some parsing. And the other thing I noticed was that the Java has a lowercase j. But I think that's probably because we're talking about the Java executable, which has a lowercase j. So we'll forgive them for that. So then we had some updates to that. And we called those 1.0.1 and 1.0.2. And if you look at the description, it says that what we now have is a major number, a minor number, and a micro number. Right. I'm happy with that. Very logical. The other thing was the class file version. So class file version was 45.0. Where did the other 44 go? Not really sure about that. Then we move on to February 1997, and we have Java 1.1. So that introduced a fair number of new features. So you could have argued that it could have been called Java 2. But OK, we'll buy into the fact that we're doing major, minor, micro. So we'll use the minor number to indicate that we've got some new features, but it's not really a big version shift. So we get Java 1.1. And the Java version is logically 1.1. OK, all good so far. But then we get into some updates. So we've got 1.1.1, 2, 3, 4, 5, 6, 7. I'm happy with that. All logical. Except for 1.1.1 is actually a CPU, or critical patch update, with only security changes, and the rest are micro versions. So at this point, I'm still very happy with the logic, until we get 1.1.7a and 1.1.7b. Why do we get 1.1.7a? Because there's an emergency patch that needs to be issued, and then it turns out that emergency patch is not done correctly, so we need to have an emergency patch to an emergency patch, and we get 1.1.7b. Now, that came out before 1.1.6_004. So why did it go from letters to underscore numbers? But OK, I think that probably makes more sense, because it's numeric. We'll use an underscore rather than a dot now. OK. And then, OK, we get class file version 45.3. Why 0.3? OK. Yes, and this was also the basis for personal Java, for devices, based on 1.1.8, just for completeness there. Then we get Java 1.2. This is where things really start getting interesting in terms of the numbering. Because, OK, so we've got 1.2, so the minor version has been revised again. That's fine. And we get Java version 1.2.0. We get 2 micro versions of that, 1.2.1 and 1.2.2. And we get updates to those, so that's all right. And finally, we get the class file version of 46. And from then on, the class file version just increments once for each major version of Java. Now, in 1999, Sun decided that Java was becoming very successful, and they needed to introduce the idea of editions for Java to indicate different technologies that were being put into different places. And so they introduced 3 editions: Micro Edition, Standard Edition, and Enterprise Edition. Micro Edition was all about embedded devices, mobile phones, things like that. Standard Edition was the core platform, as we know, so the language and so on. Enterprise Edition was application servers, EJBs, servlets, and all those good things. Which led to Java 2 SE. So now we've got a new number, new major number. Unfortunately, this is where marketing collided with engineering, and not in a good way. So we got Java 2 SE version 1.2. Why? I mean, really, why? If you read the documentation, it kind of comes down to they had a product version and a developer version. Not quite sure why there's any difference between those, but there you go. And so now, fortunately, the Java version is 1.2 point, and then so micro. So we're still doing major, minor, micro. Now, I've got to read this. OK, this is straight from the java.com website. While 1.2 was a remarkable release from the perspective of the amount of change, it had the version 1.2 versus 2.0, and it was clear there would never be another major release. Consequently, minor releases, 1.2, 1.3, etc., were referred to as major releases and micro releases as minor releases. Respectively, 1.1 is also referred to as a major release, though 1.1.1, etc., continue to be micro releases. Anybody understand that? Right. Then we got into Java 2 SE version 1.3, so next version of Java. OK, still, right, OK, we've got a little bit of consistency here because we're sticking with the 2, but now we've got 1.3. And so now the version number also adds in that underscore to give you the update to the micro version. And we get 1.3.1 as a micro version. Then we got to 1.4. Still maintaining a nice level of consistency, so we've got 4.0 underscore 04, and 1.4.1 and 1.4.2 as micro editions. All looking good. We can just keep going like this, can't we? No. No, we cannot. So we had Java 2 SE. What would you think the next version would be? Well, you'd think 1.5, wouldn't you? No, because marketing got involved again. And they said, let's have Java 2 SE 5.0. But engineering were not having any of that. So when you do version number, you get Java version 1.5.0 underscore 22. But at least it's consistent in terms of that version numbering. OK, so yeah, actually, sorry, one more thing to add about that was there was planned to be a 5.1, but it never saw the light of day. So because of that, marketing then said, right, we're going to have a tidy up of the version numbering. We'll drop the 2, because there's never going to be a Java 3, because we're already on Java 5. And now we'll call it Java 6. Great. OK, so not .0, because there isn't going to be a 6.1. Engineering still not buying in. So we got 1.6.0 underscore 45. Then, yeah, updates initially changed by 1. Then they changed by 2. Then they changed by 5. Then they changed by 10. So this is where things get all a little bit kind of complicated. So when they did an update to a particular micro edition, they would give you either 1 more, or 2 more, or 5 more, or 10 more, depending on what mood they were in. Oh yes, and then we had this special update, 1.6.0 underscore 21p. Anyone guess what that one was? Well, apparently this was because the installer for the Brazilian Portuguese version of Java had a problem. So they issued a very special patch just for the Brazilian Portuguese installer, which was 1.6.0 underscore 21p. Then we move on to Java SE 7, so we're moving the major version forward nicely, and we get 1.7.0. OK, that's all fine, and except that we now have 3 digits worth of updates, so it makes it a little bit harder to parse. CPUs have to have odd numbers. PSUs have to have even numbers, which is why you've got 331, because that's a CPU, and if you had 332, that will be the PSU. And then we get to Java SE 8, OK, still moving the major version number forward, and we got the same thing, that's all good. Now we get to Java SE 9. Okay, so we've had a bit too much consistency. We need to change things again. So engineering finally looked at this and went, you know what? Having a 1 point doesn't make any sense. Let's call it 9. Yay! So finally, we've got Java version that actually is 9 in accordance with Java SE 9. But of course, when you have an update, rather than calling it 9.1, you'll call it 9.0.1. And the reason for that is that if you look at JEP 223, they introduced the idea of major, minor security. So rather than it being major, minor, micro, it's now major, minor security. Right. Then in September 2017, things kind of went a bit Kafkaesque. And they said, right, moving Java forward faster. We're going to have a release every 6 months. Now, this is good. We've seen this work very well. You'd expect it to be JDK 10. Except no, it's not going to be JDK 10. No. We will now call it JDK 18.3. And then we'll have 18.3.4. And I'm not messing about here. There were 2 updates proposed, which will be 18.3.1 followed by 18.3.4 to indicate the year followed by the month followed by the age, and the age being the number of months since the initial release came out. Fortunately, you know, it was looked upon and people said, no, that really is just taking things too far. So we did end up with Java SE 10, and we get Java version 10, but then just to confuse people, they added the date as well. And finally, we get 10.0.2. OK, that's all good. And this is the final version string that we have at the moment. So this is, ever since Java SE 10, we've had this. JEP 322, feature, interim, update, patch. And just for completeness, Java SE 11, we had a patch to an update. So we got 11.0.15.1. Oh, and they added the LTS just to add a little bit more extra information. So like I say, interesting to see how the version numbering of Java has changed over time. Right, back to the Java story. 1997. As I said, Internet Explorer agreed to put Java into it and have that available for everybody. So here we have Scott McNeely and Steve Ballmer, all very happy. Yes, this is wonderful. Java is going well. Until Sun Microsystems sues Microsoft over the Java implementation in Internet Explorer 4. Reason for this was that Microsoft looked at Java and thought, this is good. We can make it better. And we'll make it better in an incompatible way. So what we'll do is we'll remove some of the features that Java has, things like, I think they dropped reflection, and we'll add some extra things that we like. So they added an extra 50 classes and methods in the standard Java libraries. So suddenly, if you wrote code on Internet Explorer, or that would run on Internet Explorer, wasn't guaranteed to run on the Sun JVM or JDK, or other implementations that agreed with Sun's implementation. So this was considered, you know, not a very good thing. Sun sued Microsoft, finally got resolved for $1.9 billion in Sun's favor, and the history, as we know, Microsoft dropped Java from Internet Explorer, and on off we went. Now, as Java became more popular, there was a lot of call for more openness around Java, specifically the idea of having more open standards and open source. And in 1998, there was a group of people who decided to create an open source implementation of Java, which was called GNU ClassPath. The reason it was called GNU ClassPath rather than anything to do with Java was because of the trademark. So they couldn't use Java as a trademark. They called it ClassPath because if you expand the ClassPath, most likely it's going to have the word Java in it somewhere. So they could kind of sneakily fit Java in there through an indirection into the ClassPath. They also had a thing called GCJ, which is the GNU Java compiler, or compiler for Java, and a sort of VM that they did for a while called Jafar. In 1999, Sun accepted that they needed to have more openness, and so they created the Java Community Process. Java Community Process originally had 2 executive committees, one for Java ME and one for Java SE and Java EE. Since then, various things have happened, and we now have only 1 executive committee for everything. What the JCP did was it created Java specification requests. And these JSRs could apply to any form of Java technology. So there's about 380, I think it is now, And they cover all sorts of APIs across Java ME, Java SE, Java EE, all those different bits and pieces, plus loads of other stuff as well. And the important thing about a JSR is it consists of 3 parts. So you have the specification itself, which in the case of Java core is the Java virtual machine specification, Java language specification, and a list of all the class libraries. Then you have a reference implementation. The idea behind that is it proves that you can actually implement a specification. So if you can write the code to do it, then you've got proof that the specification can be implemented. And then the third part is what's called the TCK, or Technology Compatibility Kit. And that's a set of tests which you can use to verify that if somebody creates an implementation of your specification, that it actually matches the specification. And this is very important for Java, as we know more recently, because it allows us to verify that we have compatible implementations. And that's been going on for about 26 years now. So the other thing that happened in 2005 was more people wanted open source Java. And we had the Apache Harmony project, which started creating an open source version of Java. So they wrote it basically from the specification, didn't use any source code from Sun, and they were trying to create a specification or try to create an implementation for that. Now, the problem they had was in order to verify that their specification matched the, in order to verify that their implementation matched the specification, they needed the TCK. And Sun were very reluctant to give them the TCK because they didn't like the terms of the Apache license. What that resulted in was in 2006, Sun open sourced Java. The decision was made, let's make Java open source, and we got the OpenJDK. Now, initially in 2006, we got the hotspot VM code and we got the Java C, but there was still a lot that hadn't been released. Reason for that was we needed to do due diligence to make sure that the code that was being released, Sun actually had the rights to, because of course, there are lots of people who contributed code like IBM and Apple and so on. So we went through the due diligence to make all of that available. And so in 2007, almost all the remaining code was released. It wasn't until build 53 of JDK 7 that you could build the complete thing from open source, but they got there eventually. And then, of course, in 2010, Sun Microsystems had been suffering from the fact that giving Java away meant they weren't making any money from it. Dot-com bust had caused problems for them in terms of selling hardware, and so it became clear that Sun wasn't going to be able to continue on its own, and it got acquired by Oracle. That was a bit of a shock, because I remember in 2009 being sent an email saying, we have just been bought by Oracle. It's like, oh, flip. And then we ended up with Sun Oracle. And just for completeness, this is the diagram, this is the picture that James Gosling created at the time. Coming back to Apache Harmony, it's worth kind of saying just a thing about that, which is that in 2010 and 2011, because Oracle had taken over, one of the problems that we'd seen in terms of moving Java forward was that Apache had been blocking the specifications for the next version of Java, which is why there's 4 and a bit years between JDK 6 and JDK 7, or one of the reasons, one of the primary reasons. So in 2010, when Oracle acquired Sun, they basically went to Apache and said, yeah, this is what's going to happen. We're not going to give you the TCK under the license you want. And Apache said, OK, if that's the case, we will withdraw from the Java community process, and things were then able to move forward again. And eventually in 2011, IBM, who were the primary contributor to Apache Harmony, they joined the OpenJDK project, and everything's moved forward through OpenJDK. Apache Harmony has now been discontinued. Right, how am I doing for time? Oh, badly, but OK. So let's talk about where we've seen Java used, because this is also kind of interesting. So this is a brochure that was created by Sun, as you can see, Sun Microsystems, Java Everywhere in Action. And I've tried to find various places where we've seen Java that you might not think about. So first was Java Card. This is even smaller than Java Micro Edition, and it's literally designed to run Java applications, or applets, I suppose you could say, in something which is 64 kilobytes or less. Some devices have like a megabyte, but some of them have 64 kilobytes or less. So you can't run a full JVM in 64 kilobytes. To get around that, the way that the system works is that you take your Java code, you compile it into what's called a cat file, and then you install that on what you call a secure element, which is your smart card chip. Not a full implementation of a JVM, obviously, so there's no dynamic class loading, no multi-threading, there's no char, there's no double, there's no float, there's no long. You're basically just using ints. And the libraries are very much a subset, so there's no, there's no AWT or swing, funnily enough, and there's also very little in the way of java.lang even. But there are some notable uses of this. So the Oyster card, anybody here from London, like me? Nobody. Okay. Well, Oyster is the travel card that we use in London, and you can go in and out of the public transport system and use that, and that uses Java. SIM cards, if you're not using an eSIM, you're using a physical SIM card, that has Java card on it, still being used. And there's several examples of health cards and identity cards that are being used by people in different situations. Java chips. I briefly mentioned this when I talked about the Java station. This was an idea that came about because in the very early days of Java, it was fully interpreted rather than using JIT compilation, and it just didn't perform as well as native code. So they said, right, let's just move the virtual machine into silicon and make a virtual machine that's a physical machine. And this was what they called Pico Java. Execute the machine instructions directly on a real machine, get up to 20 times improvement in execution speed. Two flavors of this were created. One was called Micro Java, and the other was called Ultra Java. Or the other code name it had was MAJC, or Magic, as we called it. JIT compilation definitely took over from that. There was really no need to do it, and it wasn't a particularly simple solution in the end, so they abandoned that idea. The Java ring. I have a Java ring. This was something that was based on a completely different technology. So Dallas Semiconductors had this thing already, which was a button that you could use to identify yourself and do various things. And so they decided to put Java on that. They gave everyone who went to Java 1 in 1998 one of these, and there was a sort of wall that you could have where you plug your Java ring in, and it would create one element in the sort of fractal thing that they had. And you could sort of do that. It was an interesting idea. I've tried playing around with it, but there's not a great deal you can do with it. The Palm Pilot. Anybody here have a Palm Pilot? Yes, okay, a few people here, right. So the Palm Pilot was very popular in the day as a PDA before the iPhone, and so they created a virtual machine for that called the KVM, or the Kilobyte Virtual Machine. And it was designed again to run in a very constrained environment down to a minimum of 273 kilobytes. It had various APIs that were specific to the Palm, like the screen, the stylus, address book, calendar, and so on. And you can see there this little sort of Duke who's juggling, and so you can run Java applications on there. The Kindle, Amazon Kindle, actually ran Java, or at least this particular version did. It used Java for the UI. It was based on Java 1.4 personal basis profile, which is part of Java ME. It had AWT with lightweight components only. And then Amazon released a developer kit called KDK, and it used the APIs and ran kindlets. Everything in Java has to be a lut. So you have applets, kindlets, xlets, all sorts of different things, servlets. But there, OK, so that was running Java. Then we had the Java Pen. This was another one that was introduced as a sort of thing at Java 1, 2008. That had penlets. So we still got to have LUTs. So we have penlet for that one. Based on Java ME, used Java SE5. Not really much you could do with that. Sunspots. Oh, yeah, these were just so much fun, right? So I've got a couple of sunspots here, and I'm just going to power one of those up there. So you can see maybe there. Oh, yeah, there we go. So we've got little sort of flashing lights. We like flashing lights, but the fun thing is, if you turn a second one on, we get some flashing lights, hopefully. Yeah, that one's supposed to change color. All right. Right. But sunspots were the idea of looking at small programmable object technology. And they were, again, a little bit too far ahead of their time. So they were way too expensive for what they were. Lots of interesting things that people did with them. It was really sort of a research project. It had a thing called the Squawk VM. That was probably the most interesting thing, which was the fact that it was a VM. A lot of it was written in Java. It was Java ME, CLDC, and so on. Mobile phones clearly was a big thing for Java in the early days. And so Java 2 Micro Edition when we introduced editions, it was all about things like this. We had configurations, in this case, this connected limited device configuration, and then the connected device configuration plus profiles, the mobile information device profile, and then lots of APIs to control all sorts of things that you would have in mobile phones, like mobile media, wireless messaging, location, and on and on and on. Java TV, another project that I actually have a soft spot for because I was involved in this quite a lot as they were developing this. And we went back to the original ideas of putting Java on set-top box. So we did a research thing with Philips, who were building set-top boxes, and I got to go to like television trade shows, which was kind of interesting. And then we had demonstrations for things like the BBC, with Wimbledon, and what we would do is have interactivity. So it was like if you had a game show or a talent show, what you could do is put up things, overlay it on the screen, and then have people vote and use the back channel on the set-top box to collect those votes and show which was the most popular one and so on. Again, it never really kind of took off because the internet really sort of filled in the gap for that. So it was an interesting idea, but yeah. Blu-ray players, again, the idea of interactivity so that we could add things to sort of more static content. So we got a version of Java ME that's on every Blu-ray player. If anybody's still got a Blu-ray player, then you have Java on there. Again, interaction. And the last thing I just want to mention for this, because I had so much fun with this. I love Lego. And Lego Mindstorms, if you remember. The version 1 of Lego Mindstorms had this little box, and it had a ARM processor on it with 64 kilobytes, not megabytes, 64 kilobytes of, no, 32 kilobytes of memory. And some people got together and they wrote a pseudo Java virtual machine for that, which I used very effectively for a number of demos. Great thing about that was, although it wasn't a full implementation, clearly, didn't have any GC, so you had to be very careful with your object allocation, but it did have multi-threading. And it could do multiple threads of execution and do all sorts of interesting things like that. So I love that. Oh, God, I've only got, OK. Evolution of the Java platform. I'll skip through this fairly quickly. So we had JDK 1.1, we already heard about. I've put up all the code names for the different versions. So we had Sparkler, Pumpkin, Abigail, Brutus, and Chelsea. No idea how they came up with those names. Must have been looking around and went, oh, look, Abigail, we'll call it after you. And then things that they added there, inner classes, Java Beans, JDBC, RMI, serialization, reflection, and JIT compilations came along in JDK 1.1 for Windows only. 1.2 was Playground, and the follow-ups to that were Nat and Cricket. That introduced the strict FP keyword, which broke backwards compatibility. I actually checked this on my machine, and you can't compile code on 1.2 that uses strict FP as a variable name, but you can on 1.1. Also introduced collections framework was big, JIT compilation for Sun JVM, and the Java browser plugin for applets to make that easier. 1.3, not really that much in there, so that was Kestrel with Firefly for the update 01 of 1.3.0, and Ladybird. Introduced JNDI and Java Sound. 1.4 was Merlin, Hopper, and Mantis. That was the first version to use JSRs, so Java SE 2 1.4 had an umbrella JSR, which is 59. Assert keyword, again, broke backwards compatibility because you couldn't use it as variable name anymore. Regular expressions, non-blocking I/O, and Java Web Start, originally in 1.3, but 1.4 finally. And then Tiger. I remember that was the big one because it had, we had, what was his name? Graham Hamilton, who was the architect at the time, on stage with a tiger, a real live tiger. That introduced lots of things: generics, annotations, auto-boxing, unboxing, enumerations, for each loops, static imports, and varargs. Oh, and the concurrency utility. So it was a really big change. And then we had 5.1, which never came out, called Dragonfly. 6 didn't actually include anything interesting. Well, there were a few things, but not really. And then JDK 7 had Project Coin, which the reason it's called Coin, firstly, is coin. You can coin a new phrase, so that's new, and coins are the small change in your pocket, so small changes. And that introduced strings in switch, try with resources, which was really good, diamond operator, simplified varargs, binary literals. Really, did it take us until JDK 7 to have binary literals in Java? Underscores in numeric literals, and multi-exception catches. Plus, we added invoke dynamic, first new bytecode in Java. Yeah, and then for completeness, JDK 6 was codenamed Mustang. JDK 8, first version to use the JDK enhancement proposals. So we've moved away from component JSRs to the idea of JEPs instead. That introduced lambdas, introduced streams API, so a more functional way of programming, new date and time API. JDK 9 was modularity. That was a big one, because one of the most important things about that was it was the first time since the Apache thing where the Java Community Process Executive Committee voted down on a JSR. And we had to go back and have some discussions about modularity, and then it got voted through. I won't go through all the other additions, because that's fairly modern, so you know about those. Just briefly talk about Java Community. Java 1 is the conference that's been around since the very beginning, 1996. And so we've had lots of different Java 1s. So you can see all my badges up there that are Java 1, and I'm about to be thrown off stage, I know, yep. So Java user groups is a great thing, because we have lots of Java user groups around the world who have been responsible for promoting Java. We have Java conferences, which we're at the moment, and lots of other Java conferences around the world. Java Champions is a program started back in 2005. Who here is a Java champion? Oh, you've got a couple of Java champions there. I think there's about 403 of them around the world. And I've got to just say one thing about the Java Sherpa, Sharad Chandler. Where is he? There he is. Round of applause for Sharad. And that is it. So yes, so just to finalize it, yeah, so Java, right technology in the right place at the right time. So bringing all those things together just happened to be at the right time, carefully nurtured by Sun and then Oracle. They've done an extremely good job of keeping Java fresh and maintaining the development of the language and the platform. Open standards, open source, very important. And it's right to say that Java is more than just a computing platform. It is an ecosystem, and it is a community, as witnessed by the fact we're all here together. Where will Java be in 30 years' time? I don't know, because I probably won't be here. But anyway, so if you want to rate my session, then you can use the QR code or 2275 as the session ID. And with that, thank you very much.